Hello student, this class will continue the previous electric field due to charger bodies concept will continue. Last class we completed electric field due to charger wire of infinite length we completed. Now we are going to discuss about finite length. Finite length means I taken one of the example here, a rod of length L, fixed length. It is not infinite, it is a finite one. Now we given the charges to this one. So when the charges are given, the charges will be accumulated on the surface of this one. So the total charge of this one is capital Q. Total length of this one is lambda. Now I taken one of the line of bisector exactly which divides this total length of the wire into two parts, that is as L by 2 from the line of bisector to above, L by 2 below. So I chosen a point here. At this point I want to calculate the electric field intensity due to this charged wire of finite length. To find this one, first you can choose the elementary portion from the line of bisector to up to the length of L by 2. So directly I can go for, already we done the derivation for this electric field intensity due to of infinite length wire or any length of the wire. So here electric field intensity due to that, to calculate here first you have to understand that, imagine a test charge to identify the direction of the electric field at that point. So you know that the direction of the electric field is always in this direction at this point. Imagine a test charge, what direction the test charge is going to repulse, this is the direction of the electric field at that point. So this electric field I conveyed as electric field E. Now to explain the concept of calculation, we are using the concept of choosing the coordinate system, x-axis, y-axis we are choosing here. So this is x-axis, this is y-axis I am choosing. So this is making an angle, some theta here. So it is also making an angle theta. Resolve this E into components. You are going to get two components here. One is x component, that is Ex component. Second one is you are going to get Ey component. Same like previous. So the total electric field at that point is equal to combination of electric field along x-axis plus y-axis. So to find the electric field along x-axis, first already we done yesterday. That means the previous class, the formula electric field along x-axis is equal to, what is the formula? 1 by 4 pi epsilon naught, that is Q by L into, in bracket we have a formula of sine theta 1 plus sine theta 2 is the formula we take. What is theta 1, theta 2? Theta 1 is the angle made by the elementary portion above the line of bisector. Theta 2 is the angle made by the elementary portion below the line of bisector. Here if you taken the line of elementary portion above the line of bisector, it makes an angle theta 1, this is theta 1. If you made the same elementary portion below, it makes an angle how much? That is theta 2 angle. So in this case, from the line of bisector above and below, length is more, L by 2, that's why this theta 1 is equal to theta 2 is equal to theta I convert. Theta 1 is equal to theta 2 is equal to theta I convert. So if you put that value in that, what you are going to get? Electric field along x-axis is equal to Q by 4 pi epsilon naught into L into sine theta plus sine theta, that becomes into 2 sine theta here. So in this case, this 2 get cancelled. So we are going to get here Q sine theta by 2 pi epsilon naught L here. Now what is sine theta? Sine theta can be calculated using this triangle. From this triangle, theta is equal to theta 1 we said. So from this triangle, if you see this one, this is the O, this is the P, this is the A. If you say from the OPA, from the triangle OPA, I can write the sine theta value. What is sine theta from the triangle? Opposite by hypotenuse. What is the opposite? This is theta. If you say this becomes opposite, this becomes hypotenuse. What is hypotenuse value? That is the distance of the point from the elementary portion or end of the conductor line. So I can write this formula, sine theta is equal to, I can write as L by 2 by R I can write. L by 2 by R. Now what is R value? R value not given. From the, this one, the point which you chosen is always, you choose it as X if you say, and the length of this wire is equal to L by 2 if you say, this R value becomes, using Pythagoras theorem, under root of L by 2 whole square plus X square. So if you apply that condition here, we have also X is also is there in the formula. So what the formula will becomes here? That formula will becomes L by 2 into, what is the R value? That is nothing but L by 2 whole square plus x square whole power 1 by 2. Substitute this value in the above equation, so you will get the electric field along x-axis. Electric field along x-axis is equal to what I can write, that is nothing but q by 2 pi epsilon naught into L into x. Okay, x into sin theta value. What is sin theta value? That is L by 2 into, that is I can write as L square by 4 plus x square whole power 1 by 2. So in this case, if you observe here, this L get cancelled. So remaining, you can write the expression as Ex equal to q by, that is 4 pi epsilon naught into x into, we can write in terms of what way we can write now. This is okay, x term if written, that is we are going to get L square by 4 plus x square. So this is the expression for electric field along x-axis. If you write in terms of charge density, what is charge density? Linear charge density here. So in this case, Ex equal to, I can write as this q by x, I can replace with the lambda, because most of the books will be appears in this form. That is lambda by 4 pi epsilon naught into, that is 1 by, so what you are going to get, that is L square by 4 plus x square whole power 1 by 2. We should not forget about this 1 by 2, that is whole power 1 by 2. This is the formula for electric field along x-axis in the case of this. Similarly, in the case of okay, y-axis. Y-axis anyway, electric field due to above portion, this is Ey component. And due to this below elementary portion, if you see, due to below elementary portion, the electric field at this point will be in this direction. So that means this electric field E, if you resolve into components, again you are going to get x component here and y component here, that is Ey. So here this elementary portion is this elementary length, both are at the distance of L by 2, L by 2. So that's why what happens here, this Ey value both are becomes equal and opposite, net will be 0. That means electric field, okay, along y-axis, that is net electric field, I can take it as net electric field, you take it, that is net electric field along y-axis is equal to becomes 0. So for the finite length of wire, we have electric field along y-axis is 0. That is equal to nothing but only electric field is due to the, okay, finite length of wire is equal to due to x component of. So this formula we can use. This is the expression for finite length of wire. Now we are going to discuss about electric field due to a charged ring. Next application. So I taken one of the complete ring. You can see the diagram. Ring means like bangle. Okay. So what we done is we given charges to this. Whenever the charges are given, the charges will be distributed on the ring. Now we'll go to the approach of what way of distribution of these charges are there. Then after we'll go for derivation of mathematical approach. So here the total charge of this okay, ring is equal to Q. If you say it is occupied across the surface of the ring, that is circumference of the ring. So here the ring is negligible thickness if you taken. In this case, the charges will be distributed as a linear charge distribution. So lambda is called linear charge distribution, that is nothing but charge occupied per unit length light. That means if you choose in a small elementary portion, the length of this one becomes L. So total charge of this one, that is what is the length of this ring, the length of the ring is equal to nothing but we can write as Q by, that is circumference of the cycle, that is nothing but 2 pi r, I can write. What is r here? R is the radius of the ring. If r is the radius of the ring, I can write the length of that one is equal to like this. So from this, what is the charge on this charge on this ring? The charge on this ring is equal to nothing but lambda into 2 pi r. This is the total charge on the ring. First step unit. Next, go to the case of what point you want to calculate the electric field intensity due to this charge. First, I chosen a point on the ring somewhere here. At this point, I want to calculate, the point is I taken as P. Now I want to calculate the electric field intensity at this point. To find the electric field intensity is one of the vector quantity having direction. So how to find the direction? To find the direction, you have to imagine a test charge at this point. So you know that positive repels. So the charge, you choose a elementary portion of length on this ring. That elementary portion charge is, you take it as dq. That dq repel this q naught. in this direction as you're looking like this. This is the direction which is going to be repulse. So this direction it is going to repulse with the electric field of intensity dE. Why I am taking dE? Because the charge is only, I taken part of a charge, a small elementary portion of length I chosen, that is dq, the length of that one we can take it as dl, right? Now what distance the point we chosen from the charged conductor? Okay, that point is chosen from the charged, okay, elementary portion is equal to how much? That is nothing but r I can take it. So the distance is nothing but r. R is the distance of the point. Now, actually, if you see this line, the point which you chosen, always we are taking from the axis of the ring. So from the center of the ring to the point, the distance is, you take it as x. As you change the point P, automatically x value also changes. So I want to calculate electric field intensity at that point P at a distance of x from the center of the ring. Now at that point, due to elementary charge dq, the electric field is dE. Now if you observe this one, it is making some angle theta here. Now I can take it as theta here. So if you resolve this dE into components, we are going to get as, that is dE cos theta, one component you will get. Second component you are going to get in the downward direction. In this direction you will get the, okay, second component. In this direction you will get the another component, that is dE cos theta. That is dE cos theta. Sorry, already we have a cos theta, so dE sin theta you get y component. So if you choose on the same elementary portion below, then what happens according to that elementary portion? So electric field at that point will be in this direction. As you're looking at this point will be, it will be upwards. So the electric field at that point will be in this direction. This is the way the electric field will be. Now again, if you resolve into component, what happens? You'll get the y component in this direction, that is nothing but dE sin theta will be upward direction and dE cos theta will be in the forward direction. So if you observe here, this is dE sin theta, y component by the above elementary portion. This is dE sin theta, y component due to below elementary portion. Both are equal and opposite because it is we chosen the uniform charge of ring. So that's why what happened, both will be cancelled. So there is no electric field along y-axis, that is due to cancellation of that one. So only we have electric field in this case, that is nothing but dx. dx equal to, simply we have to take it as dE cos theta. So if you find this dE cos theta, that is over. Now we have to integrate this one dE cos theta from complete length of the ring. So dEx equal to, I can write as Ex. So integral, what is dE? dE nothing but electric field, that is nothing but 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. The charge is on that one is due to elementary portion dq by distance of that one is equal to r square into cos theta. Now just modify. What is dq? Already we did not taken any dq. Here q is equal to how much? Lambda into 2 pi r. Lambda into 2 pi r. Now from this, what is dq? dq is equal to lambda into length of that elementary length. Okay, lambda into how much I can write? That is nothing but dl. So dq is equal to, I can replace with, that is Ex equal to nothing but 1 by 4 pi epsilon naught is constant. I am taking outside here. So lambda dq can be replaced with lambda into dl. So lambda is also constant, I taken outside. So integral remaining is, that is dl by, okay, denominator is r square into cos theta. Now what is cos theta here? That is important for us. Cos theta from the diagram, if you see this, from this triangle, cos theta is equal to x by r. Adjacent by hypotenuse is called as cos theta. So that is nothing but, from the diagram, that is nothing but x by r equal. X by r means what the formula I can write, that is nothing but Ex equal to lambda by 4 pi epsilon naught into, okay, that is x is constant position, okay, r is also according to that one is constant, we can replace with a variable later. So I can write as x by r cube, I can write, this is integral d. Now what is changing? Charge distribution is changing from, okay, complete ring from 0 length to up to the length of the complete ring, that is 2 pi r. This is the way you have to take. Now if you solve this one, what you are going to get, that is nothing but Ex equal to nothing but lambda into x by, so 4 pi epsilon naught into r cube into integral dl is equal to nothing but L. Okay, that L is, if you apply the limits, that you are going to get 2 pi r. What is r here? Radius. Now small r can be replaced with, what is small r? From the diagram, this is x, this is radius r. I can write this small r is equal to under root of r square plus x square. I can write. If you replace that one, so what you are going to get, that is Ex equal to, electric field along x-axis equal to lambda x by 4 pi epsilon naught into r square plus x square whole power, that is already we have is, okay, 1 by 2 is there, that is nothing but we are going to get 3 by 2, we are going to get, that is into 2 pi r. So we can cancel anything, you can cancel it here, 2 pi 2 times we can cancel, so electric field along x-axis is equal to lambda x r by, that is 2 epsilon naught into r square plus x square whole power 3 by 2. This is the expression for electric field along x-axis due to this charged ring. But what is the electric field due to this charged ring along y-axis? Already we done, that is nothing but is equal to dy equal to 0. So the electric field only due to along x-axis is lambda x r by 2 epsilon naught into r square plus x square whole power 3 by 2 is the formula for this. And what is lambda? Lambda can be replaced with again q by L. That L is nothing but, okay, you can write as q lambda into 2 pi r we can write, and based on that one you can replace here. Q by 2 pi r you can replace, again you can modify the equation. Now if you apply the concept of lambda, what is lambda? Charge per unit length, that is nothing but q by 2 pi r. So I can replace here with Ex equal to, that is nothing but x r by, that is already we have okay, q by 2 pi r, I can write here 2 pi r into 2 epsilon naught into r square plus x square whole power 3 by 2. So if you cancel, what we can cancel here, r get cancelled, so I can write here again 2 to the 4, I can write as 1 by 4 pi epsilon naught, that is q into x by, okay, r square plus x square whole power 3 by 2. So this is electric field due to a charged ring along x-axis. So this is the expression will be most of the books you can able to observe. So in this case, okay, if you apply the condition here, what is the condition at the center of the ring? At the center of the ring, if you take in the ring here, charged ring, what is the electric field intensity at the center? At the center, if you want to calculate what is the distance of that point, x equal to 0. Put the x value 0. If you put the x value 0, what is the electric field intensity? The electric field intensity will becomes equal to, at that point, equal to 0. So formula based electric field intensity at the center of the charged ring is 0. At the same time, concept based also we can able to explain, because here positive charge, here positive. Totally it is spread with the positive charges. Yes or no? The ring is given number of positive charges. So what happens? So this positive creates the electric field in this direction. Opposite positive creates the electric field opposite. So both equal and opposite net will be cancelled. Like that, what happens? All electric lines of forces equal and opposite, okay, get cancelled. So electric field at the center will becomes equal to 0. So at center, electric field intensity is 0. At any position of the distance along axis is equal to qx by 1 by 4 pi naught qx by r square plus x square whole power 3 by 2. We can use this expression. Now if you observe the case of this one, this is a charged ring. I taken this axis. At the center already we got electric field intensity is 0. At any point on the x-axis, the electric field intensity having value qx by 4 pi naught r square plus x square whole power 3 by 2. Already we done the derivation. But what is the direction? Along x-axis. This is important for us. This is the arrow mark which gives the direction of the electric field at that point. Now if you observe this one, this electric field as from the charger body, as they are going away from the charged ring along axis, what happens to electric field? Electric field is going to be changes, right? Here it is 0, now it is having some value, so that means electric field is going to be increases. At what distance it becomes maximum? At what distance it becomes maximum? That means This is the x value. With respect to x, E value is increasing, changing. So at one of the position, electric field value becomes maximum. That condition where the electric field is becomes maximum, so that is called dE by dx condition has to become 0 according to differentiation. So differentiate this equation. After differentiating this equation, we are getting one of the position that is called x at a position which is in terms of radius, that is nothing but r by root 2. So if you differentiate the above equation, this equation if you differentiate, okay, in the using the d by dt of x by y or u by v form, if you differentiate this one by taking the condition of d by dx equal to 0, because that is the maximum change of electric field with respect to distance. To apply that condition 0, x equal to r by root 2 you will get. That means at a position of x value at r by 2, at a position of x value r by root 2, not sorry, r by 2, r by root 2, the electric field will becomes E becomes maximum compared to any other position. That means at the center it is 0, as they are going it is increases and it becomes maximum up to the distance of r by root 2 x value, and after that again it is going to be decreases. So we have a graphical expression of this one. That graphical expression we can discuss now. Now we will discuss the graph regarding this charged ring. X-axis, y-axis, coordinate system chosen. X-axis is the distance you choose. As the distance of the point is increasing along x-axis, I am taking the same x, and y-axis is take the electric field intensity. Now initially at center, that means what is the x value is 0. When x is equal to 0, electric field intensity is 0. Now as the x value is increasing, electric field intensity also increases. So the graph will be like this. As you're looking like this, the way the graph is going to be changes. So in this case, the value of this electric field intensity will becomes maximum at one of the position. This is called E maximum. So this maximum value of electric field intensity takes place at a position of x equal to r by root 2. So this is a graphical representation. After that again what happens, the electric field intensity value is going to be decreases. It will be, you can take it as according to the relation. So this is one of the graphical expression for variation of electric field with respect to distance graph for the case of charged ring. Now next application, electric field due to charged ring, that is one of the semicircular ring or half semicircular wire. Also they will give the question, what is electric field intensity at a point. So in this case what I am doing, at the center we are calculating in this case, not at any point. First I taken one of the wire, you can see this is the wire which is bent in the form of semicircle. I given the charges onto this, so that is plus q charges I given. This is the way the charges are going to be distributed on this. Now in this case I chosen a small elementary portion here. This elementary portion length I am calling as dl. The charge on this one is I taken as dq, as okay given here. Now due to this, what is happens, there is electric field intensity. You can see the direction of this electric field. This is the direction of electric field here, that is d. Because due to small charge dq, electric field is d. So resolve this into component, because whatever the line joining here, whatever the elementary portion we chosen here, if you taken the line joining here, below portion, above portion, it touches and the angle is different. So theta is the angle made by that one. If you say this angle nothing but I can write as d theta. That means the elementary portion which you chosen at the center, it's subtend an angle of d theta. So according to that one, what I can write here, this dE making an angle theta with respect to x-axis. If you resolve into component, one component you will get as dE, okay, that is nothing but dE cos theta component you get. Second component you are going to get as dE sin theta component here. So here x component, like if you are taking that x component is dE sin theta, y component is dE cos theta. Suppose if the same elementary portion if I choose on this side, then what happens, you will get dEy in this side. So that means dE cos theta nothing but dEy, dE cos theta, both are becomes equal and opposite, net will be 0. That means in this case I can write dEy value will becomes equal to 0, but dx value is not become 0, that is equal to nothing but dE cos theta. So this dE cos theta changes from where to where, the theta value changes from here to here, that is 0 angle to up to what angle you can choose it, up to elementary portion up to here, that means 180 degrees up to pi angle you can choose it, 0 to pi you can integrate. So complete. What is electric field intensity at this point to calculate? You can apply the integration from 0 to pi limits. So I can apply here integration dx integral is equal to, that is integral d. What is the d formula? 1 by 4 pi epsilon naught is the basic formula, into charge is dq by distance. What is the distance here? R is the radius of this one, that is only the distance of the elementary portion. I can write as r square into cos theta we can write. Now limits is 0 to pi. So in this case, what is variable here? The variable is theta is the variable. As the position of the elementary portion changes, theta value changes. So what I can do, integral dx equal to, I can write as dx is equal to 1 by 4 pi epsilon I am taking as constant k dq. What is dq? dq nothing but charge. Okay, in this case, what way the charge distribution takes place? The charge is distributed in this case, that is linear charge distribution lambda. Lambda is equal to nothing but q by, that is total circumference of the circle, nothing but half of the circle. What is the half of the circle length? That is pi r. So total charge is equal to lambda into pi r I can write. So total charge is equal to lambda into pi r I can write. So elementary charge dq is equal to lambda into, what is the length of this one? The length of this one is equal to, I can write as dl. So I can write dq is equal to nothing but lambda into dl by capital R square into cos theta. Now what is dl? According to the concept of radius, this dl nothing but arc, it acts like an arc. This is radius theta. So I can write the arc in terms of, okay, theta is equal to arc by radius. Theta is equal to arc by radius, that is dl by radius. So what is dl? R into, okay, theta. Here theta is what? D theta. So I can replace here Ex equal to nothing but k into lambda is constant, take it outside. R is also radius of the semicircle also constant, take it outside. Integral dl I can replace with what? That is r into d theta into cos theta. So if you solve this one, Ex equal to nothing but, that is here 1r get cancelled. So I can write k lambda by r into integral cos theta d theta. Integral cos theta d theta is equal to what? Sin theta. So what are the limits we applied here? That is 0 to pi we applied. That is, you can apply 0 to pi. If you apply the limits, what you are going to get? For this complete semicircle Ex equal to, that is k lambda by r into cos 180, okay, is equal to 0. That is also 0. That's why what you do is from 0 to up to half of that, you calculate the same thing will get it here. That means you can write from here, okay, elementary portion if you choose in here, elementary portion if you choose in here, that is minus theta. If you choose on this side, that becomes plus theta. So what you do is you take the limits, change the limits, not 0 to pi, you take the limits from minus pi by 2 to pi by 2. Minus pi by 2 to plus pi by 2. If you taken minus pi by 2 to plus pi by 2, sine, okay, 90 becomes 1, that becomes 2n. So k lambda by 2 you will get. K lambda by 2 means, what is the expression I can write? I am writing in different color to understand. Final answer, that is Ex equal to, okay, so what is k? K is nothing but 1 by 4 pi epsilon naught, that is nothing but I am writing as 2 lambda by 4 pi epsilon naught into r I am writing. Here 2, how many times cancel? 2 times. So final answer Ex equal to lambda by 2 pi epsilon naught r is the answer. So electric field intensity at this point, okay, due to only x component, that x component value, how much you are going to get? Lambda by 2 pi epsilon naught r. This is for which one? Semicircular charge ring electric field at the center.